Kia ora Year 12. This is a difficult excellence question from the 2016 Level 3 calc paper. And it's a question that's a classic, and it's in the old Delta extension exercises. It's a little bit like the one we did in class the other day, if you're in my class, where you have to choose how far you walk on one kind of ground and then how far you walk on another. But it's kind of actually nothing to do with that, so we'll forget about that picture. What we've got here is a really lovely diagram, and if we use the diagram well, this question is doable. We're told that we've got a rugby game, and we've got a try that's being scored 15 metres from the left-hand goalpost, and they have to take a conversion kick. So the choice here is about how far back the player goes. So we have to choose D, and we have to choose D so that the conversion kick maximises the angle theta between the lines from the ball to the goalposts. So when you look at this, you've got to be thinking trig, Pythagoras, or similar triangles. And this is very clearly going to be a trig problem. I've got one triangle that looks like this. Here's D, and here's alpha. And this length is 15 metres. And that's a right angle triangle. So I look at that and I think tan. Then I look at the next big triangle, and I see in here alpha plus theta. I've got D here again, and now I've got 20.4 metres. So I'm going to do something with that. We want to maximise angle theta. So let's start by writing down some stuff about tan, and then think about what to do, because I think that's going to be the hardest step. We've got to use calculus, and we've got to differentiate, right, which is really shouldn't be that surprising by now. So let's start by writing down two equations for tan. So do that first. Sorry about the noise. I'm trying to find my paper. Right, so we can get tan alpha is equal to 15 over D. And then from the second triangle, we get tan of alpha plus theta is equal to the full width, so 20.4 metres over D. Now, we want to get an expression maybe for theta, but we can start by looking at this and saying, well, this here is some kind of compound angle thing. So let's not think about theta just yet. Let's think about tan of theta. So tan of theta is equal to tan of alpha plus theta minus alpha. And this should make you think of the compound angle formula. All right, so let's just have a look at that. So tan of A minus B is equal to tan A minus tan B over 1 plus tan A, tan B. Right, so we're going to work with this as being A and B. So tan of theta is equal to tan this minus this, which will be tan of alpha plus theta minus tan alpha over 1 plus the two tans that we've got together. Okay, so tan alpha plus theta times tan alpha. Okay, the thing you're probably thinking though is, why is she just talking about tan of theta? Isn't our goal to maximise theta, not tan theta? Well, if you're in the A-level class this year, it's a little bit like what Nicholas was saying today when we were trying to maximise the area. Instead of maximising the area, we can maximise the area squared, and we'll get the same answer. So here, if you think about maximising theta, we know that we're going to be looking for an angle somewhere between 0 and 90 degrees. So tan of theta is increasing with theta in the range 0 to pi on 2. So that means that to maximise theta, we can maximise tan of theta. So what we want to do, and we're going to come back to the algebra in a sec, is we want to find the distance that's going to do that. So we're going to get D is equal to all of this. And then we're going to say, no we're not. We're going to say tan of theta is equal to blah, blah, blah as a function of d. And we're going to differentiate not theta, but tan theta with respect to d. And we're going to set that equal to 0 for a maximum. Okay, so you can see that I'm already at 5 minutes and we haven't really even started the problem. But this is the trickiest part of the problem. If you can think about this idea that you don't have to maximize an expression for theta directly, then you're halfway there. I'm scrolling back up to this compound angle thing. So here's my tan theta, and this is what I'm going to try and maximize. But we know all of these expressions. We know this one, we know this one, and that's the same stuff again. And they are simple functions of d. So the next part of the task is to substitute in those two expressions and see what we get. I'm really sorry about all the scrolling. I hope no one's feeling seasick, but there you go. So tan theta is equal to 20.4 over d minus 15 over d over 1 plus those two times together, 15 over d times 20.4 over d. Right, we've obviously got a whole bunch of cleanup to do. The numerator gives me 5.4 over d divided by the denominator, which is 1 plus 306 over d squared. Right, so cleaning up some more, 5.4 over d, dividing by a fraction is the same as timesing by the reciprocal. I'm going to have d squared over d squared plus 306. So that's that bit there. That simplifies to 5.4d over d squared plus 306. So that is my expression for tan theta. I'll show you in class tomorrow another way that you could have got there, not using that particular version of the compound angle formula. But for now, this is how we've got tan theta. So the next thing we've got to do is to say this. For a maximum, we want d tan theta by d equal to 0. So we're now going to differentiate. We've got no trig left. We're just into the product rule. So d tan theta by dd will be, using the quotient rule, we get this, differentiating the numerator 5.4 into d squared plus 306 minus 5.4d times the derivative of this, so that's 2d. Now we need that to equal 0. This is always positive, so we can forget about it. We can multiply through by it. So what we've got to work with now is 5.4d squared plus, I think that worked out to be, what was that, 1656.4, horrible numbers, but it's all going to come out really well now, 10.8d squared. We want that to equal 0. That gives me 1656.4 is equal to 5.4d squared. D squared is equal to 306.7407, giving me d is equal to 17.5 meters. Okay, so that's the final answer. Please leave me a comment if anything in here doesn't make any sense. I really do think this is a tricky problem for level 3 for two reasons. The first reason is that you've got a spot that you don't know how to work with differentiating a tan inverse. Okay, so it's actually quite doable, but it's just not something we teach at level 3. So that's not going to help you. So you have to see that to maximize theta is the same as to maximize tan theta. I think that's quite tricky. The other thing that's hard in here is that you've got to be really confident with your compound angle formula, and you've got to see how we got back to tan of theta from in here. Okay, so let me know if it doesn't make sense, and I'll try and explain a little bit better.